to 2. I'm going to take a random matrix. I want to give the coordinate vector. All right, so I need to write A, B, C, D as a linear combination of 1, 0, 0, 0, 1, 0, 0, plus 0, 0, 1, 0, plus 0, 0, 0, 1. All right, so I'm going to take A times this, B times this one, C and D, and that's going to give me the right answer. And so that means that the coordinate vector is just A, B, C, D. All right, so the reason I did this example, even though it's easy, is it's a bit striking because it shows you that there's a relationship, and we saw it in many examples that the two cases were so similar. There's a relationship between 2 by 2 matrices and R4 that we could see as going from a matrix to a coordinate vector if you take this basis. And that means the two vector space are really kind of relabeling of the same one. But what we're doing is even stronger than this because we can build this coordinate vector for any vector space and any basis. And so what we'll get then is if I get a basis with n element for vector space V of dimension n, the coordinate map phi b relative to b is the function that takes any element of V and sends it to its coordinate vector. All right, so that's a map from M22 to R4, but it's a map from any vector to Rn. Turns out that map is really nice. It has an inverse, so it's 1 to 1 and onto. It also respects the vector structure, but we'll see later on how it does that in chapter 2. All right, so just to finish, I want to just really spell out this map in the example we did a bit earlier on. So example 1.5.13, we'll be looking again at this basis for E3. So that's the same one we had in example 1.5.11, same basis. Give the map phi b from R3 to R3. So phi b sends the elements x, was it xyb or abc that we took, sends abc to, and that's from part C of example 1.5.11. It takes it to minus a plus 3b minus 3c minus 4a plus 10b minus 9c, and then 2a minus 5b plus 5c. And really, you could think of it as Q inverse times ABC. All right, give the inverse map. Well, that inverse map, I'm going to use, this is phi, and this is psi. I'll keep them like that for all of chapter 2 as well. So for the second one, I want to go from a coordinate vector back to the original vector. That direction is easier because all you have to do is you have to put the vectors here and then multiply by whatever components you have. And so more precisely, if I have a vector C1, C2, C3 here, I will get C1 times 5, 2, 0, plus C2, 0, 1, 1, plus C3, 3, 3, 2.